Let's look now at Part C of this problem, where we are asked what is the probability that at least 17 of the 20 households have access to high-speed internet. Now, at least 17 means the smallest value is 17, but it could be 18, it could be 19, it could be 20. So we need to find the probability of 17, 18, 19, and 20 households. Alright, I'm going to go and flip over a couple of slides here now to the solution to this one, and I'll talk over this. Alright, so as your note here says, at least 17 means 17 or more. We need to find a probability that x is greater than or equal to 17. Now, problem with doing this in Minitab, as we're going to find out, is that Minitab doesn't do greater than or equal to. It only does precisely equal to, or it does cumulative probabilities, which are written as less than or equal to. So there's two ways we could approach this problem. We could find the individual probabilities of 17, 18, 19, and 20 and add all that together. So that's what's going on right here. Or it says we can use cumulative probability, and if we're going to use that technique, then we're changing our setup to include something that includes less than or equal to. Alright, let's just have a look at how this would work. So right here on the next slide, I got Minitab to give me the probabilities that x is precisely equal to, and notice it says probability density function. So the probability that x is precisely equal to 0, 1, 2, 3 all the way down to 20. And I'll take you into Minitab in a minute here now and show you how you could do this. So if we were going to answer the question by finding the individual probabilities, those are all right here. I add them together. My answer is going to be the 0.41145. So that's one approach I could take. But the other approach I could take, which actually is faster, is to use the cumulative distribution function. But when you use cumulative, you're dealing with less than or equal to's. Now, if I were to get Minitab to give me the cumulative distribution for every value of x, so here's the probability x is equal to 0 or less than 0. Now, by the way, you can't have negative numbers, so this is the probability x is equal to 0. This is the probability x is equal to 1 plus the probability x is equal to 0. Now, I know the answers look like they're the same number, but that's because these probabilities are so small. Minitab rounds off to 5 places after the decimal. These numbers might be 0.0000356. I mean, I have no idea, but they're rounded off to 5. So all of these cumulatives, this one includes 1 and 0. This one includes 2, 1 and 0, 3, 2, 1, 0, 4, 3, 2, 1, 0, etc. And when I get down here to the bottom, I'm looking at the probability of right here 14 or less, the probability of 15 or less, etc. until I get down to the bottom. And when I get to the bottom, I've now included the probability that x is equal to 20 plus the probability x is equal to 19, 18, 17, 15, 14, all the way back to 0. Now, in our case, x, the number of households who have high-speed internet out of 20, x can only be a value that falls between 0 and 20. So by the time I get down to here, I'm looking at the probability over all possible values of x. Total probability is always equal to 1. And when you do cumulative probabilities, you're going to find that the numbers increase until generally you get down to your last one, which is equal to 1. Now, the approach I'm going to take here is that I'm going to take the total probability, which is 1. I've got that right here. I am looking for the probability x is greater than or equal to 17. Well, alright, greater than or equal to 17 includes the numbers, as I have over here, 17, 18, 19, and 20. But another way to look at this problem is to take the total probability over all values of x and subtract from the total probability the probabilities of the numbers I don't want. Well, I don't want 16, 15, 14, all the way back to 0. Minitab gives me probability of 16 or less. Here it is at the 0.588. So I've set my problem up. I'm looking for probability x is greater than or equal to 17. That is the same as finding the probability, it's the same as taking the total probability over all values of x and subtracting from that the probabilities of the numbers you do not want. So if I take the 1 minus 0.588, I'm going to get exactly the same answer here as what I would get if I was to add these four values together. Using cumulative distribution is faster than using the individual equal to probability. In this case, it doesn't really make a whole lot of difference. You're adding up four numbers as opposed to subtracting two numbers. But suppose n was equal to 100. Suppose we chose 100 households and you wanted to find the probability that more than, 25 or more of them had access to high-speed internet. Doing it this method over here, you would have to find the probabilities of 25, 26, 27, blah, 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 all the way to 100, and you'd have to add all those probabilities together. It would be simpler if you used cumulative probability. All right, so let's just go to Minitab for a second and we can have a look at this. I have put in, let me see, now I have to drag this down a bit. I've put in the numbers in column C1. I've put in the numbers 0 to 20. I don't have to do this, but I just want to show you how this would work. If I go to the Calc tab, Probability Distributions, and the Binomial, instead of inputting one particular number, I could, if I wanted to, put in a whole column of numbers. So here I'm inputting all the numbers that I have listed in column C1, and that includes the numbers 0 to 20. I don't have to do anything about storage. This is optional. And if I say OK, scrolling up, here's the cumulative probabilities going from 0 down to 20. And notice that my probabilities, the cumulative probabilities, increase, increase, increase until I get down to the last number where the total probability over all values of x is equal to 1. Now I could do a similar thing, but rather than using cumulative probability, I could look for the individual probabilities of all these numbers individually. They're all in column C1, which I've called X. Click OK, and this time I get the probability density function. These are all probabilities that X is precisely equal to each of these values. And notice how they do not sum to 1, because these are probabilities for individual values of X, whereas if I scroll up here, these are all probabilities of a number and all the numbers that are less than it. So if I look at this one right here, that 0.79392 is the probability of 17 or less. So in answering this question, all I need to know really, in part C of the problem, is what is the probability of 16 or less, and subtract that value from 1. What will remain will be the probability of 17, 18, 19, and 20. Or, as I've shown you in your notes, the other way you could do that is to find the probabilities individually of the 17, 18, 19, and 20 and add those four probabilities together. So choice is yours.